For as long as we've looked up at the sky, we've wondered, are we alone? Well, today we're diving deep into Mars. We're talking strange signals, bizarre images, and some pretty groundbreaking science that might just finally give us an answer.
Okay, so it all kicks off with images just like this one, beamed back from NASA's Curiosity rover. I mean, look at it. You've got this vast, empty landscape, and then this figure seems to just emerge from the shadows. You can imagine this single photo just blew up online. People were seeing everything from ancient statues to, a lonely Martian just watching the rover go by.
And believe me, that shadowy figure, that's just the tip of the iceberg. Over the past year or so, Mars has been sending us a whole series of puzzles, stuff that has even the experts kind of scratching their heads. So you've got this mysterious figure, right? Then there are these weird kind of egg-shaped things all clustered together on a rock. And maybe the strangest one of all, the actual sound of lightning on a planet where, there shouldn't be any thunderstorms. I mean, it's so easy to let your imagination just run wild with this stuff, right? But here's the thing. While all these weird sights and sounds are super fascinating, the real hunt for life on Mars, well, that's happening on a microscopic level, a scale you can't even see with the naked eye.
And this right here is where the story gets really, really interesting. NASA's Perseverance rover has officially found something incredible. They're called biosignatures.
So what's a biosignature? Well, we're not talking about little green men or alien fossils here. Think of it more like a chemical fingerprint, a tiny molecular clue left behind in the rocks that basically screams, hey, life was here.
And this amazing instrument is how they're doing it. It's called SHERLOC. Yeah, like the detective. And it is the rover's master sleuth. It's got this super specific, methodical way of sniffing out these fundamental signs of life.
So here's how it works. SHERLOC is basically a robotic geologist. First, it finds a rock that looks interesting. Then it uses this super high-res camera to get a really close look, almost like a magnifying glass. After that, it analyzes what the rock is actually made up, chemically speaking. And if it finds anything juicy, it flags it for the scientists back on Earth to take a deeper dive. And just recently, this whole process paid off in a huge way. I'm talking about July 18th, 2024. SHERLOC zeroed in on one particular rock, a rock that might just change everything we thought we knew about Mars. Okay, so the rover targeted this specific rock. They named it Giaz, and it was sitting right in the middle of what looks like an ancient riverbed. When the data started streaming back to Earth, scientists noticed spots on this rock with a very surprising and honestly, a very familiar chemical signature. And this is the connection that got scientists so pumped. See, back here on ancient Earth, some of the very first microbes got their energy by munching on iron phosphate compounds. And guess what? The Giaz rock on Mars is absolutely loaded with that exact same stuff. It's a direct parallel. And when they dug even deeper into the data, two key minerals popped out. The first one, vivianite, is a mineral that on Earth we almost always find right next to decaying organic stuff. And the second one, greigite, well, here on our planet, that's a compound that's actually made by living microbes. So you see, this isn't just some random coincidence. It's a really powerful chemical clue. Okay, so now that we've got a handle on the real science, the hard evidence, let's go back. Let's circle back to those mysteries we started with and see if we can solve them. First up, what about those weird eggs all clustered on that rock? They definitely look out of place, right? I mean, were they laid by some kind of Martian creature? Well, the answer is actually way more cosmic, but less biological. See, Mars has this super thin atmosphere, and it's right next door to the asteroid belt. That means it just gets hammered with meteorites way more than we do. So those eggs, they're just small, weirdly shaped iron-nickel meteorites, visitors from space. And what about that shadowy figure, our mysterious watcher? It's a classic case of our brains playing tricks on us. It's not a person at all. It's just a rock, standing at the perfect 90-degree angle to cast that spooky, human-like shadow. You know how you see faces in clouds? It's that. Our brains are just wired to find patterns, and there's a name for it: pareidolia. All right, last one. Let's tackle that sound that seemed totally impossible, that lightning, on a planet that doesn't have the big, water-filled storm clouds you need to make it. Now get this. Perseverance has actually recorded 55 of these so-called lightning events in just a couple of Martian years. But hold on.
Before you start picturing massive thunderbolts crashing down on the red planet, you need to know we are talking about something completely different.
The difference in scale here is just massive. Lightning on Earth is a monster, right? It's miles long, carries millions of volts. The lightning on Mars, it's created in dust storms, it's just a few centimeters long, and it carries a teensy-weensy static charge.
And the science behind it is something you've actually felt yourself. It's called Triboelectric charging. Fancy name, but it's the exact same thing as getting a little static shock when you take off a wool sweater or shuffle your feet on the carpet and then touch a doorknob. Zap. So what it boils down to is this. These are tiny microscopic sparks. They're just static discharges happening as billions of little dust particles rub up against each other in a storm. If you were standing right there on Mars, you wouldn't see a thing, you wouldn't hear a thing. It's only because the rover has these ultra-sensitive instruments that we can detect them at all. So what's the big takeaway from all of this? I think it's that the real search for life on Mars isn't about spooky shadows or weird-looking rocks. It's all about chemistry, the hard evidence, the stuff like the minerals they found in that geysers rock. That tells a story that is so much more exciting than any optical illusion. It shows us that Mars is this dynamic world with a really complex history that, honestly, we're just starting to piece together.
And all of this leaves us with a pretty profound final thought, doesn't it? Finding these biosignatures totally changes the game. The biggest question might not be, was there life on Mars anymore? Now it's, what did that life look like? And maybe, just maybe, is any of it still there?